Hello everyone, it's Professor Capko again. Today we're going to learn another type of word problem. This is actually in response to a student's question. I've got a word problem here that's very similar to the one that the student asked for. It's slightly changed just to make it interesting. Alright, so I've done some word problems already in some other videos. You may want to watch those first just to get the basic techniques, and we're going to apply those techniques to this problem. In this one, we've got Cindy and her husband, Frank, and they drive to the store. Cindy gets there in 30 minutes. They're driving separately, and Frank drives an average of 10 miles an hour faster and gets there in 20 minutes. Now, we're assuming they live together and they drive from the same spot. What is Cindy's average speed? Okay, so we're going to try and figure this out. So I'm going to take what we know, and I'm going to kind of draw it out here. I like to draw, so they're going from point A to point B, and they're both going the same distance because they're both going from the same point A to the same point B. We're going to just assume that from this problem. And we know Cindy gets there in 30 minutes. And we know that her husband, Frank, gets there in 20 minutes. We are trying to figure out Cindy's average speed. We don't know what it is, and that's what the problem's asking for, so I'm going to make that my x. I recommend that whatever the question's asking for, make that your x each time, because that way once you've solved for x, you've solved the problem. Don't make something else the x and then have to work through it to get back to the answer to the problem. Just when the problem says what is blah blah blah, I know what my x is. So right here it says what is, and is, remember that's the equal sign. What is Cindy's average speed? I know that is going to be my x when I write this problem out. Alright, we don't know what her average speed is, but one thing we do know, we know there's a formula called distance equals rate times time. So your distance is equal to your rate, which is your speed, times your time. Now, it's not a complicated formula, and it's really not hard to memorize. You really use it all the time. If you think about if I told you you're driving on the highway at 50 miles an hour and you drove for 2 hours, how far did you go? Everyone knows you went 100 miles. You took your rate, 50 miles an hour, and you multiply it by your time, 2 hours, and you got your distance, 100 miles. So this is going to be our key formula. Okay? So I'm going to set this up as Cindy's distance is equal to, I'm going to call it distance sub c, so I know it's Cindy's distance, is equal to Cindy's rate, so it's rate sub c, which stands for Cindy, times time sub c, which is telling me that's Cindy's time. And then we've got Frank's distance, so distance sub f for Frank, is equal to Frank's rate, so rate sub f times time, which is Frank's time, so time sub f. Okay, so now I've got a formula to show the distance Cindy went and a formula to show where Frank went. Now we know Cindy's average speed. What is Frank's speed? Well, we don't know. All we know is Frank, we know from here Frank drove 10 miles an hour faster than Cindy. So Frank's rate is, the equal sign is. We know Cindy's speed, Cindy's rate, is 10 miles an hour faster, so we're adding 10 to that. So Cindy's rate, we know is x. We don't know what it is yet, but we've called it x. That's what we did up here. So x plus 10 is equal to Frank's rate. So rate sub f. Okay, so now we've got pretty much all the things we need to solve this problem. Now we're going to set it up. As I mentioned earlier, since Cindy and Frank live together, we know that the distance Cindy traveled is equal to the distance Frank traveled. They both came from the same house and both went to the same store according to the problem. Well, now we can substitute. What can we substitute in for the distance Cindy went? I just pull out the distance Cindy went and I left an empty box there, labeled it D sub C. Well, over here, we set up D sub C is equal to R sub C times T sub C. So I can substitute R sub C times T sub C. And on this side, I've got the distance Frank went. Well, I can pull that out. I'm going to label my box distance Frank went. And over here, we know distance Frank went is equal to R sub F times T sub F. So the rate Frank went times the time for Frank. So it's looking more like an algebra problem. Now let's substitute some more here. For my R sub C, the rate Cindy went times Cindy's time is equal to the rate Frank drove times Frank's time. So I just pulled out those variables and left empty boxes there labeled. What could I put into the rate Cindy went? Well, the rate Cindy went, that's X, so we're looking for, so that's the X. The rate Frank went, that's X plus 10. Now we need to know the time. Well, we know Cindy went 30 minutes and Frank went 20 minutes. Since we're looking for the miles per hour, the average speed, that's what the question's asking for, the average speed. Usually that's going to be in miles per hour unless it tells you otherwise. So we need this in miles per hour. So we got to convert our minutes to hours. In 30 minutes is easy, that's half an hour. 20 minutes is a third of an hour. I would like to leave these, since a third is a little bit cleaner than doing 0.33333, I'd like to leave each of these as fractions. So Cindy drives for half an hour and Frank drives for a third of an hour. So now we've got a formula. I've got X times 1/2 is 1/2 X equals, and I've got X plus 10 times 1/3. So this really looks like an algebra problem. Okay, so let me get us some more room here. I'm going to rewrite this on the next page just to give us some more room to lay this out. I'm just rewriting the same thing. I've got X times 1/2 is equal to 1/3 times X plus 10. So I've got a fraction on each side here, and if you watch my video, Friggin' Fractions, we know one way to get rid of fractions is to multiply by a good common denominator. So we've got a 2 and a 3. If we don't know the common denominator between them, we just multiply them by each other. 2 times 3 is 6, so we're going to multiply both sides by 6. So 6 times 1/2 X equals, and multiply this side by 6. 1/3 X plus 10. These should be brackets. So now I can multiply each side by the same thing. As long as I'm doing it to both sides, it stays in balance. 1/2 of 6 is 3, so it's 3 times X. 1/3 of 6 is 2, so I get 2 X plus 10. See how I did that? 1/3 times 6, so 1/3 of X. 1/3 of 6 is 2. 1/2 of 6 is 3. So 3 times X is 3X. I've got to distribute because this is a polynomial here. It's actually a binomial. So 2 times X is 2X. 2 times 10 plus 20. Getting very close here. We're going to solve for X. I want to get my X's on the same side. I'm going to move this X over there. Subtract 2X from both sides. And this side I've got x, there's a 1x, but that's an invisible one. We don't usually write that. Is equal to 20. Looks like a solution there. 20 miles per hour for Cindy's rate. And then if we want to know Frank's rate, we know it was 20, whatever Cindy's rate was, plus 10 is equal to 30 miles per hour. And you could check it by plugging them back in, and I've shown you how to do that in some other videos. But hopefully that will get you started on that type of problem, and that's how you do it, so we can solve actually both rates with one problem. So I hope you enjoyed this. Hope it was helpful to you. If it was, click like. If you have other questions, put them in the comments, and make sure you keep your grade alive and subscribe to my channel. Thank you. Till next time, this is Professor Capko.